Okay, now in this video, we're going to be doing some angle proofs. We're going to use the information that we just went over, and now we're going to prove some of these, and we're going to do it. You're going to see a lot of similarities between angle proofs and between those segment proofs. So, proof number one, let's go ahead and get started. Proof number one says that PQR is a right angle. So therefore, let's prove that PQS and SQR are complementary. So technically what you're trying to prove here is actually here. Right angle implies complementary. So we're trying to prove the complement theorem. However, here is a rule. You can't use a theorem to prove itself. So let's try to use all of our other information to prove this complement theorem. First off, we're given that the measure or angle PQR is a right angle. That's our given. So therefore, the measure of angle PQR is 90. And that can be found right here by definition of a right angle. Now this works forwards and backwards. If it's 90, it's a right angle. If it's a right angle, it's 90. All definitions are biconditionals. So therefore, that would be, again, definition of a right angle. Okay, next up it says the measure of angle PQS, which is this angle, plus the measure of SQR, which is this angle, is equal to the whole angle measure. That's your angle addition postulate. And in the next step, we're simply going to combine 2 and 3. If PQR is 90 and PQR is also equal to this, so we can replace that. And you can say either transitive or substitution here, then PQS plus SQR has to be 90. And finally, if two angles add up to equal 90 degrees, then they are complementary. Let's find that on our sheet. And it is right here. If they add up to 90, they're complementary. If they're complementary, they add up to 90. Biconditional, works both directions. That would be definition of complementary angles. Okay, number 2. We're given that angle 2 is congruent to 3, and 1 and 2 form a linear pair. So let's go ahead. Angle 2 is congruent to angle 3 is given. And we can go ahead, notice that the whole linear pair stuff, they write it down here in 3, but it's also given. You can put it all in step 1 if you wanted to. So if two angles are congruent, that means that their measurements are equal. That is definition of congruent. And also, from step number 3, again, we always take our given and we say, okay, from this given, what do we know it has to be true? So if 2 is congruent to 3, we know that they have to be equal. If they form a linear pair, then we know it has to be supplementary. Now, again, this is the one that I like to call something else. Linear pair implies supplementary. That's called, in my book, the linear pair postulate. So let's go back. And that step number 4 is the linear pair postulate. Okay, step number 5 says that 1 and 2 add up to 180. Well, that follows from them being supplementary. If something's supplementary, then that means the two angles must add up to 180. That is the definition of supplementary. Okay, but now let's go back and look what we're trying to prove. We're trying to prove that 1 and 3 are supplementary. Well, we're given that 1 and 2 are supplementary, and we're given that 2 and 3 are the same, so that means that we could replace that with that transitive property, so 1 and 3 would also be, and that's all they've done here. They've taken out, and you can use the transitive property, or since we know that from up here, the measure of angle 2 and angle 3 are the same, you can say either transitive, or actually it's not transitive, it would be substitution here because we're taking this out. They're not both equal to the same thing. So we're taking out 2, plugging in angle 3 in its place, so that would be the substitution property. And then finally, now that we know they add up to 180, that means that they are also supplementary because, again, it's a definition, and definitions are biconditional. They work forwards and backwards. We actually use the definition to go to here, and then we're using the definition to go backwards. So they're 180, so therefore they're supplementary by that same definition. Okay, the next one. Number 3. It says given angles 1 and 2 form a right angle. Measure of angle 1 plus measure of angle 3 is 90 degrees. So 1 and 2 add up to 90, and 2 and 3 also add up to 90. So both of those are 90-degree angles. And we're trying to prove that angle 2 and angle 3 are the same measure. So first off, we're given that angle 1 and 3, or 1 and 2 is a right angle, and 1 and 3 add up to 90. So both of those are givens. And then step number 2 says angles 1 and 2 are complementary. Now, you got to be careful here. A lot of people say that, oh, right angle, that's complementary. That's the definition of a right angle, but that is incorrect. Definition of a right angle says if an angle is a right angle, it measures 90 degrees. Okay, the actual definition of a complementary says if two angles add up to 90, then they are complementary. So if you put those together, yes, one implies the other. However, going from right angle to implying complementary is actually right here. Right angle implies complementary is the complement theorem. So that's going to be the reasoning behind number 2. And then down to number 4, okay, we're given that 1 and 3 add up to 90. Why do we know that 1 and 3 are complementary? And it's not the same reason. Going back to our sheet here, it says that if your sum is 90, then that implies that we're complementary. That's the definition of complementary angles. So that's going to be the reasoning behind number 4. And then we jump straight into number 5. So here's how we're going to do that. We're going to take our statement from number 2 and our statement from number 4 that says angles 1 and 2 are complementary, angles 1 and 3 are complementary. If two angles are complementary to the same angle, then those two angles must be congruent. That is your congruent complements theorem. If A is complementary to B, C is also complementary to B, then the two are congruent. Again, that is your congruent complements theorem. Okay, on to number 4. Given that BE bisects, now this is another one of our definitions, BE bisects ABD. So here is BE and here is ABD, so that's a bisector. Also BD bisects, and here's BD, bisects this angle. So therefore, first off, our givens, and we could have actually combined a lot of stuff here. We're given that BE bisects ABD, and we're also given that BD bisects EBC. Now, let's go back to the actual definition of angle bisector. By the definition of an angle bisector divides an angle into two equal parts. So we're going to have two angles that are equal to each other, angle measures that are equal to each other. So that's the reason we have measure of, actually, I don't like the way that they wrote this. Since it says the measure of two equal parts, so therefore we should have actually said the measure of angle ABE is equal to the measure of EBD and went from there, but we'll go along with what they've said here with congruent. So that would be the definition of an angle bisector. And the same thing here, since BD bisects EBC, that means that these two will be equal in measure or congruent. So like I said, there probably should have been an extra step there, but we'll go along with what they've got here. And again, that would also be the definition of an angle bisector. And now from there, since ABE is equal to EBD, and EBD is congruent to DBC, then that means that this angle must equal this angle, and that's our conclusion here, which is actually what we were trying to prove, and that would be by either substitution or the transitive property. But we do need to be careful here because this is congruence, the transitive property of congruence, not the transitive property of equality. Number 5, we're given that RSU, which is right here, RSU is congruent to VST, which is right here. So therefore, we're going to try to prove that this large angle is congruent to this large angle. That's what we're going for. So pretty much we're adding angle USV to both of those small angles and saying the big angles are also equal. So first off, we're given that RSU and VST are the same. And before I go any further, this is very similar to one of the last proofs that you did last section for line segments, where you're given that this is equal to this and you were asked to prove that this was equal to this as well. You're just adding the same amount to both sides. So a couple of different ways you could work this. Since they are congruent, that means that they are equal in measure, and that would simply be your definition of congruent. Next up, we have RSU plus USV, which is this angle and this angle. Add up to RSV, which is the whole angle, and you've got the same thing on the other side. That would be your angle addition postulate, and that's going to be actually both of these statements are going to be your angle addition postulates. Or excuse me, both of these statements. And again, those could have actually been combined into the exact same step. You didn't have to do that as two different steps. And then finally on step number 5, it says the measure of RSU plus USV is equal to UST. And all we did there was used our substitution. We knew that VST was the same thing as RSU. So we took out VST right here. The rest of the statement was the same, and we simply plugged in a measure of angle RSU, and again, that would be the substitution property of equality. And now look what you have. RSU plus USV is UST. We could have actually nearly done 2 steps in one right there, but back up right here. We also have RSU plus USV, just like I do here. Here it's equal to RSV, here it's equal to UST, and that's what we're trying to prove, that those two things are equal. So by the substitution or transitive property, then we know that they must be equal to each other. And then finally, if they are equal, then they must be congruent by the definition of congruent. Okay, the next one, number 6. Given that 1 and 2 are complementary and 3 and 4 are complementary, prove that 1 and 4 are the same. So we've got to use our drawing here. So again, 1 and 2 are complementary, 3 and 4 are complementary. Not sure why they're listing that in 2 separate steps, except for just maybe they didn't have enough room. So those are your givens. And by definition of complementary, if 2 angles are complementary, that means their sum is 90. So that's the reason I can say the measure of angle 1 and 2 is 90. Same thing, measure of angle 3 and 4 is 90. And again, that is by the definition of complementary angles. And instead of writing that again, if you want to just put some ditto marks, meaning that, well, it's the same thing as the one above it, that would be fine too. Next up, we have the angle 2 is congruent to angle 3. Now let's look back at our drawing. Why would angle 2 be congruent to angle 3? Angle 2 and angle 3 are vertical angles. Reminder that if you have 2 lines that intersect, the angles that are across from each other are vertical angles. And if 2 angles are vertical, then they are congruent. And that can be found right here. If 2 angles are vertical, then they are congruent. That is the vertical angles theorem. So that's the reason that angle 2 is congruent to angle 3. And if they are congruent, again, let's change that to equals. And you do have to do this step because everything that we know involves equality instead of congruence. So that'd be your definition of congruent. Okay, now let's look at our next step. Where are we headed now? Angle 1 plus angle 2 is equal to angle 3 plus angle 4. Now, why is that true? They actually combine statement 3 and 4. Now, the order here is not important. I would have probably put this step actually right after 3 and 4. But 1 and 2 add up to 90, 3 and 4 add up to 90 if they both add up to the same amount. If A equals B and B equals C, then A equals C. That is your transitive property. Now, this is a neat little trick that we're going to do now. Let's see what happens. We know that 2 and 3 are the same size. Here's 2, here's 3. You could actually skip this next step and just subtract off 2 and 3 from both sides, but what they've done first is they went ahead and changed 2 into 3, and that's perfectly fine, and that's because of substitution. And now that I've got the measure of angle 3 on both sides, I can now subtract that off of both sides, and we're left with what we're trying to prove, which is 1 and 4 being the same. Now, why can you just subtract that from both sides? Is because of your subtraction property of equality, saying as long as you're subtracting the same amount, which I could have probably made an argument I could have just done it there because we're subtracting the same amount from both sides. But we used our subtraction property of equality, and we end up with a statement, the measure of angle 1 equals the measure of angle 4. So therefore, we know what we're trying to prove now. Angle 1 is congruent to angle 4 because if they're equal in measure, then they're congruent by the definition of congruent. Okay, the next one. Number 7. 1 and 4 are congruent, which is this and this. Angles 4 and 5 form a linear pair, which is these two angles here. Let's try to prove that 1 and 5 are supplementary. And notice that we're all mixed up on this one. So angle 1 is congruent to angle 4. That is our given. And by the definition of congruence, therefore, we know the measure of angle 1 would equal the measure of angle 4. Also, from our given, we know that 4 and 5 form a linear pair. And if they form a linear pair, we can go back to our sheet here. Then we know that they are supplementary. Linear pair implies supplementary. That is your linear pair postulate. Okay, next up, notice the reasoning is the definition of supplementary angles. Definition of supplementary angles says if 2 angles are supplementary, they add up to 180. So therefore, since angle 4 and angle 5 is supplementary, that means their measurements, the measure of angle 4 plus the measure of angle 5, would have to equal 180 degrees. And since we're trying to prove that 1 and 5 are supplementary, since we know 4 and 1 are the same by substitution, we can say the measure of angle 1 plus the measure of angle 5 is also 180 by that substitution property. And now since 1 and 5 add up to 180 as well, that means that 1 and 5 must be supplementary by the definition of supplementary. Okay, number 8. Okay, it says angles 1 and 2 form a linear pair. Angle 2 and 3 add up to 180. So again, we need to develop a plan here. Angle 1 and 2 form a linear pair. So that means they're supplementary. They add up to 180. 2 and 3, which is here and, let's see, 2 and 3, which is here and here, also add up to 180. Well, if they both add up to 180, that means they must be equal to each other. So that means that 1 and 2 must be the same thing as 2 and 3. So if you notice that, hey, there's a measure of angle 2 on both sides then. So take that away and you're left with 1 and 3 must be the same. So that's kind of the path we're going here. So number 1, angle 1 and 2 form a linear pair. That is given to you. And if they form a linear pair, then that means that they are supplementary. And again, they call that the supplements theorem. I call it the linear pair postulate. So we're also given, the second part of our given is that angle 2 and angle 3 add up to 180. And if they add up to 180 again, that is by the definition of supplementary angles, we know that if those two angles add up to 180, that they're also supplementary. And now we have a very handy theorem that says if two angles are supplementary to the same angle, and notice that that same angle is that angle 2. Angle 1 and angle 3 are both supplementary to angle 2. If two angles are supplementary to the same angles, then those two angles, which are 1 and 3, have to be congruent. And that theorem is right here. It's called the congruent supplements theorem. Two angles congruent to the same angle, or excuse me, two angles supplementary to the same angle are congruent. The congruent supplements theorem. There you go. Okay, and number 9 tells us first off that AB is perpendicular to BC. So there is AB and BC, which would be right here. They're perpendicular. 2 and 3 are complementary, meaning that they add up to 90. So now let's try to prove that angles 1 and 2 are the same by filling out their proof. So we're given, again, that AB is perpendicular to BC. So the definition of perpendicular says perpendicular lines form right angles. So going back to this, if we have perpendicular lines, that means we have a right angle, and that is the definition of perpendicular. And since it is a right angle, now this seems a little, extra steps here, but we have to go through it. Perpendicular implies right angle. Right angle says the measure of that angle is equal to 90 degrees. If you actually go back and look at the definition of a right angle, which is right here. A right angle equals 90 degrees. So now, next step says the measure of angle 1, which is right here, plus the measure of angle 3 is equal to the measure of angle ABC. So this angle plus this angle equals the whole angle. That is your angle addition postulate. So now we can combine those last two steps. If the measure of angle 1 and 3 is ABC, well, ABC is 90. So we can plug that in by substitution. That means the measure of angle 1 and the measure of angle 3 is also equal to 90. And again, you could make an argument for, well, I thought that was transitive. Transitive is fine. So since the measure of angle 1 and 3 is 90, by the definition of complementary angles, that means that angle 1 and angle 3 are complementary. Okay, now look in step 7, we have another given. So we got to go back up and look. And we were given also that angles 2 and 3 were also complementary. So now we know that 1 and 3 are complementary, 2 and 3 are complementary. Since two angles are complementary to the same angle, again, this is called the congruent complements theorem. If two angles are complementary to the same angle, then that means that those two angles are congruent. So angle 1 is congruent to angle 2 by the congruent complements theorem.